Hello everybody. So in this video I'll be discussing some of the problems from week 2. Uh, these problems you can find in file section on Quarkus under tutorial. I'll be discussing questions which were given in handout 2. So the first problem asks us to calculate the domain and the range of function f of x equal to 1 divided by 2 plus x square. A general approach for these kind of problem is basically to make sure that the denominator never goes to 0. Why? Because if the denominator goes to 0, then basically these kind of function becomes 1 by 0, which are undefined. So to calculate domain, the only condition which we need to apply is to make sure that 2 plus x square is never equals to 0. Now, if you try to solve for what is the value of x here, you'll get square root of minus 2. Now, square root of minus 2, it's not a real number. It's not a real number. It's a complex number. Complex numbers are basically out of the scope for this course, so we won't be discussing about it. So you can see that the only value which x is not allowed to have is a value which is not a real. So all the real values are basically in the domain of this function. So that's why we can say that the domain is basically equal to all the real values. Now, for calculating the range, the first approach which I like to apply is basically graphing this function. Graphing these functions can be tricky, but if you try to follow few steps, then it's super easy. Try to always find the value of these functions at some critical points. That will basically give you what kind of shape these kind of function make on a graph, and then you can make a very educated guess about the range. So for example, let's see here. So this function is basically 1 divided by 2 by x square. Few of the points which we can take is basically, let's see what is the value of this function at minus infinity, around roughly. What is the value of this function at 0, and let's see what is the value of this function at infinity. So if you try to plug in the value of minus infinity, this is an approximate approach because of course you cannot plug in infinity. What do I mean by saying infinity or minus infinity is a very large number. So if you just plug in a very large negative number here, what is going to happen? It's going to first of all do a square. So if there is a square, then the minus sign will go away. So it would be 2 plus some very big number. And if you divide 1 with that number, it will tend towards 0. It will not directly go towards 0, but it will tend towards 0. Please pay attention to the terminology. It's not equal to 0, it tends towards the 0. Now what about if you plug in infinity? So if you try to plug in infinity, what do I mean by infinity? What I mean is basically a very large positive number. So if you plug in a very large positive number in place of x, what you will get is basically you will just square it and then add it to. So again, it would be a very, very large number. And if you divide 1 divided by a very large number, you will get a very small number. So again, I can say that as you try to put infinity in this function tried to go towards 0. Now what happens if you just plug in 0? So you can easily plug in 0, right? So the function goes 0 square. So the value what you will get is basically half. So at 0, this function is exactly equal to half. So if you try to make a graph for this, let me use some other color. Okay, so when you are, this is x, this is y. Okay, so when you are at minus infinity, your value is somewhere around here. Again, when you are at plus infinity or like a very high positive number, you are still here, and at 0 you are at half. So you can just connect these points and the graph should look like this. So that is why now you can see that this function can have a value from 0 to half. So that is why the range is basically 0 to half. If you see these parentheses, the square parenthesis means that value is included. So you can see here that when you are plugging the value of 0, you're exactly getting half, right? But when you're plugging a very high value, you are going towards 0. Not exactly, it's asymptotically going towards 0. So that is why 0 is not included in this set, but half is. Nice. So let's see this problem. So again, in this problem, you can see you are asked to find what is the domain and what is the range of this function. Again, this is like last problem. So what we are just gonna do is make sure that the denominator doesn't go to 0. Why? Because if the denominator goes to 0, then this becomes some form of c divided by 0, which is undefined. So the only condition which is not allowed uh, in domain is basically x square minus 16 should not be equal to 0. And if you try to solve it, it will come out to be square root of 16. It should not be equal to square root of 16. And what's the square root of 16? It's plus minus 4. Please remember that you put a negative sign as well, because the square of 4 minus 4 is also 16. So it should always be plus minus 4. So the domain of this particular function can be any value except plus or minus 4. So we can say that the domain is equal to x goes to x should not be equal to plus minus 4. There is another way of representing the same thing. We can say that the domain is from minus infinity to minus 4 union minus 4 to 4 union 4 to infinity. So now we'll try to find the value of range for this particular function. Uh, what we'll be doing is we'll try to graph this function and then see what is its range. Uh, the best approach to graph these kind of function is to calculate the value of f of x at certain values of x. You might ask like what values of x you should select. So from my experience, it's always good to know the value of fx at the edges of domain. So for example, like here, your domain does not contain plus or minus 4. So it's always nice to know what is the value of this function near to plus and minus 4. So that's what we are gonna do. So let's say first we'll try to calculate a value of fx at x equals to value which is slightly less than minus 4. So this is how I'm going to represent it. So this minus sign means slightly less than minus 4. Of course, we cannot exactly put minus 4 because that is not in the domain. So for example, I mean, value like this could be minus 4.0001, something like that. Then we'll try to calculate what is this f of x at a value which is slightly higher than minus 4. For example, minus 3.9999, or you can just keep on adding nines here. Uh, we are also interested in what is the value, let's say at values which are slightly less than plus 4. So this is how I'm going to represent a number which is slightly less than minus 4. So example of this can be plus 3.999, and then we'll try to compute what is the value of fx at a value which is at the value of x which is slightly higher than 4. So maybe 4.0001, something like that. So now let's just plug in these value and see where does what's the value of f of x. So if you plug in a value like this here, what you'll get is minus 4.001, and when you'll plug it here minus 4.001, due to square the negative sign will go away, and now you can see that it would be just square of 4.0001, which would be slightly bigger than 16, right? Because the square of 4 is 16, so square square of 4.0001 would be slightly higher than that. So x square would be slightly greater than 16. So if you subtract them, this would be very close to 0. Let's say 1. It would be approaching to 0, but it would be positive. Why? Because x square is greater than 16. So you can see that we are dividing a negative number with a very, very small number. So what does that mean? It means that it would be a very big negative number, which I'm gonna represent by minus infinity. So minus infinity doesn't mean exactly like infinity. It means a very big very big negative number. Similarly, if you try to plug in this value, what you'll get is something like this. But now if you just square it again, the minus sign will go away, but 3.99 is basically less than 4, right? So if you square 3.99, it would be slightly less than 16. So in this case, the x squared is slightly less than 16. So what you can say, it's still going towards 0, but there is a negative sign here, something like this. You can just cancel these. So again, what you are doing is basically uh, dividing a number with a very, very small value. Again, check. So these are not accurate value. What I am trying to tell you is like where we are, like which value it's trying to approach. So for this case, it is gonna approach infinity, right? Again, infinity here means a very, very big positive value. You can do the same exercise for this and this, but from these two value, we can definitely conclude that the range of the function goes from minus infinity to plus infinity. So if I just graph it quickly around minus 4, what you'll see, if this is minus 4, uh, then uh, values which are slightly less than minus 4, you are somewhere around here, and for value which are slightly greater than minus 4, you are somewhere around here. Now if you just complete this graph, what you'll basically get is something like this. So now you can see uh, that the range basically goes from minus infinity to plus infinity. And another way of just saying this is that the range basically includes all the real values. I would also like to discuss few very interesting cases which I saw. First is, let's assume that there are two functions f of x. First, f of x is just x, and then there is another f of x, which is x squared divided by x. Uh, if you closely see this function, this is also equals to x, right? It's because you can cancel the x from denominator to and 1x from top, right? But even though these two functions looks similar, their domain is not similar. Here, the domain is all x, basically x belongs to all the real number. All the real number are basically its domain. But in this function, you know that the denominator cannot go to 0, right? So in this case, the domain would belong to from minus infinity to 0 union 0 to infinity. So it includes all the numbers except 0. Uh, it's interesting, isn't it, that all the two functions, they look same, they might have two different domains. So that's why it's very important whenever you're trying to calculate the domains or ranges, don't try to simplify your expression, uh, because then you might lose some part of information. Again, I think the same thing could be said about, let's say, if you have a function x plus 1, or let's say if you have a function f of x, square root of x plus 1 raised to the power 2. If you try to calculate the domain for this, what you'll get is this is the x belongs to real number, but here it would be what, x x plus 1 needs to be greater than equal to 0, so x needs to be greater than minus 1. So here the domain would be uh, basically from minus 1 to infinity. Although you can see that it's similar expression, but the domain is different. So let's see this question. So in this question, we have to find the zeros of this particular function. How can we find zeros of this particular function? Oh, before that, what does zero of the function means? Actually, it means x-intercept. So let's say if you have a function whose graph looks something like this, then zeros of this particular function f of x basically means these 2 points, this point and this point. How can we find this? We can find this by putting y equals to 0 in these equations. So if we plug y equals to 0 and then try to solve for x, then we'll get the zeros of the function. So let's just plug these value and equate it to 0. What I can do is add 1 to both sides, then this equation looks something like this. Uh, Now if I square both the sides, uh, then this will look like something like this. And then if I subtract 2 from both the side, if I subtract from minus 2 from here and minus 2 from here, then the equation is x equals to 1 minus 2, which means x equals to minus 1. So this is the zero of the function, or sometimes we call it the solution of this particular equation. So this is another very simple problem. It says that there are certain bacterium which grows only in a circular region, and the radius of this circular region is given by r of t, which is a function of time, where time is measured in hour, since a circle of 1 centimeter radius of a bacterium was put into the culture. Now the first question it asked, express the area of bacteria as a function of time. So to solve this question, all you have to know is what is the formula to calculate the area of the circle. So the area of the circle is given by pi r square. Uh, Here you can see that radius is a function of time. So what you can do is just write it by rt of square. Now if you just plug in the value of r here, what you'll get is area is equals to pi 6 minus 5 t square plus 1 whole square. Yep. So now you see that now the area is also a function of time, which is easy to understand, right? I mean, if the radius is a function of time, then anything which is dependent on radius will also become a function of time. So you can represent a as a of t because now it changes with time. Now let's go to the second question. Find the exact and approximate area of bacterial culture in 3 hours. So the difference between exact and approximate area basically comes from the value of pi which you are taking. So if you take the value of pi to be 22 by 7, then it's an exact value. But a lot of times we are just good with the approximate value of pi, which is 3.14. So if you want to calculate the exact area, then what you have to calculate is basically uh, 22 by 7 and 6 minus 5 uh, t. So you can replace this t with 3 square plus 1, and then you just square it. I can write it properly here, I guess. Let me write it in a in a in a in a better form. Yep. So the area would be 22 by 7, 6 by 3 square, my plus 1 whole square. So this is the exact area. Now if you just replace this 22 by 7 with 3.14, you'll get an approximate area of the bacterial culture. So this is another one of those simple problems. So they are asking you to calculate the slope of the line which passes through these 2 points. So if you have 2 points, x1, y1, and x2, y2, then the slope can be found by y2 comma y2 minus y1 divided by x2 minus x1. So if we take this to be x1, y1, this to be x2, y2, then if we just plug in these values, it's 1 minus 4 divided by 1 minus of minus 2. Just make sure this is minus, so it's very important you take care of the sign. It would be minus 3 divided by 3, which is minus 1. So the slope is minus 1. Just out of curiosity, how does this line look like? The point is minus 2 comma 4, so it is somewhere around here. Minus 2, 4, and another, this is 1 and 1, so somewhere around here. So the line must look like something like this. So it's a decreasing line. So let's see another problem. It's again one of the easiest problem which you'll solve in this worksheet. So they have given you a polynomial and asked what is the degree of this polynomial. So the degree of any polynomial is basically the highest power of x, or like whatever variable is being used. So here you can see the variable they are using is x, and the highest power of x is here, which is 2. So the degree of this polynomial would be 2. Simple, right? It's very simple problem. Any zeros. So as I discussed in last problem, a zero of any polynomial basically means what are its x-intercept. And how can we find the x-intercept? By just putting y equals to 0 or fx equals to 0. So if we do the same here, so if you just put fx equals to 0 and try to solve for what is the value of x here, uh, then you will get this expression. Now from your quadratic equation knowledge, why I'm saying quadratic, because this is x raised to the power 2, right? So you know that the solution to a quadratic equation can be given by minus b plus minus square root of b square minus 4ac uh, divided by 2a. So in this equation, a is 2, b is minus 3, and c is minus 5. So if you just plug in these number, let's see what do we end up with. So this is minus b would be minus of 3, so which would be plus 3 plus minus b square would be 9. This is minus 4. What is a is 2, and what is c? C is minus 5. Divided by 2 into 2. So this is again 3 plus minus. This is 40. This would be plus 40, 49. So square root of 49, it is 7. So square root of 49 is 7 divided by 4. So if we take plus first, it would be 10 by 4. If we take minus, it's gonna be minus 1. So these are the two uh, zeros of the function. So whenever if you see the plot of this function, what you'll see that if this is, let's say, x-axis and this is the y-axis, then the function will intersect with x-axis at 2 points. First would be -1 and the second intersect would be x equals to 10 by 4. Now it asks is if there is any y-intercept. Now how can you find the y-intercept? To find the y-intercept, what you'll basically do is put x equals to 0. So if you plug in x equals to 0 here and try to find what is the value of f of x, so f of x at x equals to 0 is 2 of 0 square minus 3 of 0 minus 5. So if you see, it's just minus 5, right? So this is the y-intercept. Now what is the end behavior? End behavior can be easily seen by drawing the graph, or maybe just by seeing the sign of the a. So usually in quadratic equation, if a is positive, the parabola open upwards, and if a is negative, it open downwards. Uh, so you can see that this has +2, so it means that the parabola open upwards. So that's why the end behavior means that as the x will go towards infinity, even y will try to go towards infinity. If you cannot figure it out, maybe you can quickly draw this graph to find it out. So you know what are the x-intercepts, and you know what is the y-intercept. So y-intercept is -5, right? So you can see that this graph is going up. So as the x is increasing, the value of y is also increasing. So the end behavior can be answered by making a rough graph. Uh, Let me clean some of this area for the last part. Uh, So the last question asks if this function is even, odd, or neither. So what's the definition of even function? It means a function is even if f of minus x is also equal to f of x. What does that mean? If you take that function, you replace all the x's with minus x, but if still the function remains same, then it's an even function. What is odd function? Odd function is like, if let's say if you are putting x equals to minus x, then what you get is minus of f of f of x. And what is neither? It's like if none of these conditions are satisfied, then this equation is neither even nor odd. So for this, we know that f of x is equal to 2x square minus 3x minus 5. So if we just replace this with minus x, what's going to happen? It would be 2 minus x square minus 3 of minus x minus 5. So you see, if you try to solve this, what is minus x square? It would be x square, right? So this is x square. But what is this? This is this minus, and this minus would multiply with each other to get plus 3x, and this minus 5 remains minus 5. So is this equation equal to this equation? No, right? Because maybe 2x square is same, minus 5 is same, but here it's a negative sign, but here is a positive sign. So these two are definitely are not equal. So they are definitely not the even function. Is there any way you can express f of minus x to be minus fx? No, right? Because if you what you can do is like try to take one negative sign out, then what will happen is this 2 will become -2, and this -5 will become plus 5. So you cannot even say this. So that's why this function is neither. It's neither odd nor even, because it's not even following this one, nor it's following this one. So now let's see this problem. This is again one of the most easy problem which you'll ever get. All you have to take care is you should know that which equation is valid for which region. So for example, if you see this function, there's a clear demarcation between two regions. So there is one region, uh, so let's say this is x, this is y. So one region is less than equal to x equals to 0. So uh, they're talking about this region, uh, and this region contains x equals to 0. And then there is one region which is x greater than 0. So this region, and make sure that the region, make sure to remember that the region 2 does not have x equals to 0. So let's see let's try to graph them. How can we graph them? We can probably take few values. So you can see that x is included in the first region. So let's try to see how does this equation looks like. One of the points which you can see is that it's a quadratic equation, so it will look like something like a parabola, and its coefficient is positive, so it would be somewhat opening in the upward direction. But let's just plug in the value. So let's see what is the value of this expression at x equals to 0. If you just plug in x equals to 0 here, what you will get is 0 square minus 3, which is minus 3. So when x is equals to 0, the value of y is minus 3. So this graph is somewhat around here. So let's see, this is the value of minus 3. Uh, Now let's see what is its 0. I mean, what is its solution? So how can we find the solution 0? Just by plug in f of x equals to 0. So what value of x you are getting this to be 0. So if you try to solve for this, what you will get is square root of plus minus under root 3. And now you know that this expression is only valid for negative regions. So that's why you can only take x equals to minus 3. And you cannot take x equals to positive 3, because this is not valid for that region. In that region, this equation is correct. So one of the point is 0 comma minus 3, and another point would be this would be minus 3 square root of minus 3 comma 0. So if you just join them, this function will look something like this, at least in this direction. Now what about in the second region? So in second region, you can see that the expression is a little different. How can we calculate this? Uh, how can we graph this? Let's see what is the value of this function near about 0. Of course, x equals to 0 is not included in this domain, so we can just we'll try to see what is the value of this function near about 0. So let's say maybe x equals to 0.000001, something like that. So if you plug in a very small value, what you'll see is it's almost 0. So the value of this would be positive 1, or somewhere around positive 1. uh, so maybe what you can do is you can start from here. So it would be around, if this is plus 1, then this starts from somewhere around here. Maybe I can use another color pen. So yep, somewhere around here. Let's see what is its solution, or what is its x-intercept. How can we calculate the x-intercept? Just by putting f of x equals to 0. So if we put f of x equals to 0, then let's try to solve for x. So x will be 1. So this line intersect axis at 1. So what we can do is this is another point. Now we can just join these 2 points. Also, why it's a straight line? Because it's x raised to the power 1. So this is the same line. I'm sorry, it not looking good. Let me redraw it. Yep. So this is how the function looks like. Please remember that x equals to 0 is part of region 1, not of it's not a part of region 2. So now let's try to calculate these three values. So f of minus 3. Now minus 3, where does it lie? Does it lie in the first region or in the second region? Since minus 3 is less than 0, it definitely lies in the second region. So which equation we'll use? We'll use this equation. So f of minus 3 is minus 3 square minus 3. So it would be 9 minus 3, which is around 6. Perfect. Now what about f of 0? So that means what is the value of fx at x equals to 0? Uh, so it's very important to remember that 0 is part of region 1. So that's why again you will have to use the same equation. So if you just plug in 0 here, 0 square minus 3 will give you minus 3. So f of 0 is minus 3. And that's actually we have already calculated here also. Now what about f of 2? f of 2. So f of 2, the value 2 is more than 0. So definitely this f of 2 would be given by the second equation. So if you just plug in f of 2 in the second equation, what you'll get is minus 2 plus 1, which is basically minus 1. So these three were the solution. The only thing worth noting is just remember, where does the boundary point lies? Does it lie in the first region or in the second region?